Hi, this is Richard C. I'm a math tutor here at Wyzant, responding to a question submitted by a student. What's the limit at infinity and negative infinity of this radical? So we're going to answer that. I think whenever I'm doing domain and range, and whenever I'm doing limits, I like to have a graph. In general, I like to have a graph anyway. I think most of us are visual thinkers. So let's just start thinking in terms of a graph. We'll put this in now. We'll just say y is equal to the square root of t squared minus 4. I think we want to start with a discussion of domain and range here. First of all, there's an implied positive on this square root. It doesn't say plus or minus square root, it's just plus square root. But the main thing here is the domain. You see, t squared minus 4 has to be greater than or equal to 0, which means that t squared has to be greater than or equal to 4, which means that t itself, t has to either be less than or equal to 2, negative 2, or t has to be greater than or equal to positive 2. Now, that's our domain. The range here, because this is an implied positive, the range y itself would be greater than or equal to 0. So let's look at the graph very quickly. So here's 2, here's negative 2. Now when t is 2 or negative 2, you're going to get the square root of 0, which is 0. But then as t gets more and more negative, you're going to have a curve that looks like this. And the same thing on the right. When t is 2, y is 0. But as t gets bigger and bigger, the square root just gets bigger and bigger. And so now we can say that the limit as t approaches negative infinity, let's call this f of t here. F of t, that's going to be infinity. And the limit as t approaches positive infinity, so as t gets bigger and bigger here, f of t gets higher and higher, so f of t approaches infinity. And that's all there is. So it's a fairly straightforward question, but you see the key to getting this question is domain and range. You really have to be thinking this way and also drawing a diagram. Now, the student here is always asking, are these limits to negative infinity and positive infinity, are they always going to be the same? See how the limit as t goes to negative infinity is infinity, and as t goes to positive infinity, it's infinity. So he or she is thinking, oh, maybe that's always the way it is. No, it's not always the way it is. So I'll give you an example of simple function, let's say exponential growth. And so here's x, here's y. Y equals, let's say, 2 to the x power. Now when you graph that, you're going to get a curve that looks like this. When x is 0, y is 1 here, so 0, 1 would be the y-intercept. And it's going to be asymptotic. It's going to get closer and closer to 0, y equals 0 here as you go further out to the left. As you go further out to the right, it just gets bigger and bigger. So let's call this g of x So the limit as x approaches negative infinity of g of x is equal to 0. And the limit as x approaches positive infinity of g of x is equal to infinity. So that's a simple example, exponential growth. You've seen that in school. By the time you study limits, you will have seen exponential growth and decay. And so that's an example of how the limit as x approaches negative infinity is different from the limit as x approaches positive infinity. Okay, so I think that answers everything on this one. Good luck with limits. Limits can be tough at first, but you'll get them. Just keep at it. All right, that's it. See you next time. Bye-bye.